everybody here in the room and watching later at a later time. Welcome to Earth Engine for Non-Coders. I'm Karin Tuxen-Bettman. I'm a program manager on the Google Earth Outreach team. And I have been a remote sensing scientist since 1999. About then. And a GIS specialist. And so while I consider myself somebody who's pretty technical, I'm definitely not a programmer. I'm not a coder. I'm a scientist, and I want to make the use of data and analysis. And so if you guys if that describes you, or even if you are not a scientist or not a data scientist or a remote sensor or a GIS specialist, you've come to the right place, because what I'm hoping you guys leave with today is just a little more understanding of Earth Engine, the tool. You guys are able to get your hands dirty, and then you know where to find more resources. You know a little bit more to get yourself into trouble, which I think is a good thing, because then you maybe get a little more excited and you see what the possibilities are. But I guess my first advice is always to not be afraid to ask questions, and always to find somebody either in your organization or in the Earth Engine community or a Googler that can help you. It can answer your questions. It can unblock you along the way, because the best thing for people who are non-coders with Earth Engine is to just find collaborators and all work together. So with that, let's all get started together. I'd like to introduce my co-presenter, Genevieve Patenaude. She's here. She's going to take over a little bit in the middle and talk to you guys about Blox, which is a company and a tool that they are developing to basically give a no-code interface to Google Earth Engine and data science, remote sensing tools like that. So I'm really excited for her to demonstrate what the tool is and to answer your questions at the end. All right. The first thing I want you guys to do is go to this tiny URL. I hope it works. I just set it up before. OK, good. You're going to need, if you want to do the hands-on portion, you're going to need this, because what we're going to do is we're going to copy and paste code from the slide decks into the code editor. And this is really important, because even though you may not feel like you're coding, you actually are. Like all the software engineers at Google, they will not admit it, but some of them write code, that's true, from scratch, right? But most of them modify code, and they take other people's code and build on it, or they take code they wrote the year before and use it for something else. And so being a code modifier is just as powerful as being a code writer. So that's what we're going to do today. We're going to take the code, copy it, and paste it, so you get excited, and you can then change some of the parameters and see the changes in real time. OK, so the first step, stop what you're doing, look up here, because if you don't have this part nailed, then you won't be able to keep going. If you guys are already Earth Engine users, i.e. you have an account, and you can go to code.earthengine.google.com and see the code editor, then you're in good shape. But if you don't, then you'll want to go to signup.earthengine.google.com and just make sure that you have access. So for example, if you've used Earth Engine before in any capacity, this summit or past experimentations, then you're fine. Make sure you're logged into the same account that you did then. But if you have never, you're going to need to sign up. By the time we get to the hands-on session, hopefully it'll work out. And if not, then we might be able to call a friend, call in a favor, and get you guys expedited, because sometimes certain emails might get not automatically passed through in the sign-up process. All right, so what we're going to do today is I'm going to give you a very quick introduction to what Google Earth Engine is, and then give you a quick introduction to remote sensing. This is one or two slides, one slide, I think, that covers like an entire degree of remote sensing. OK, that's not true. But it is like some of the basics that I think are most important. And basically what I tell my dad or my good friend that comes over for dinner, like, what is remote sensing? And I say it in this way. And I think it's interesting, and I find it interesting, so hopefully you do too. And hopefully it sets the stage for like what we're actually doing when we modify the code and look at the remote sensing data and make value from it, take value from it. I'll talk about the different parts of Earth Engine. We'll get familiar with it. Then Genevieve is going to give an introduction to Blox, and we'll show more resources for more learning. Hopefully we'll have time for questions. And if we don't, I'm sorry, but we're here, and I'll be here all through dinner. I think Genevieve will too. So you can find us by the fire pits, and we can answer your questions there. So hopefully we'll have time, but if we don't, we'll find time. So what is Google Earth Engine? So Google Earth Engine is not just one thing. It's a platform. If it's one thing, it's a platform. But it is many things that combine together into that platform. The first there on the left is the data catalog. Google Earth Engine has a ton of data, right? The petabytes, it's not even worth saying, because this is going to be outdated soon, because satellite imagery are coming down in near real time, all the time, every day being added. And so that number is just ticking up. And that is pretty powerful, because if you want to start building on data that's coming in right now or yesterday or today, like that's what you need. You need that data coming down. And so you can build upon that near real-time data. It's a computation platform. It basically allows you to use application programming interface, or APIs, different commands that represent geospatial functions, though all of that language, all of what the language is telling the computers to do, the computers in the data center to do, that's the computation platform. And then it crunches the data to do what you want it to do. And then finally, we see Earth Engine, in addition, the very important detail of this is the collaborative ecosystem. That's you guys. If you go, it's not just, we have like a Google group that is a developers list where people ask questions all the time. There's a big community on Stack Exchange. There's this community when we go to places like AGU, EGU, Living Planet Symposium. These are conferences where we talk to you guys, we talk to others, they talk to us. And so it's very collaborative, because we need to know what additional computation platforms we need to add, or computations we need to add, or what data needs to add. So this is a very big part of it, and this is what I hope you're getting through this week, because we talk about it a lot. So that's really what the whole Google Earth Engine is all about. But when you guys start using it, you're probably more interested in, okay, I have data that Google's providing via the data catalog, but I also have my own private data. I have my data from the field. I have all this data that I want to combine together. So you want to collect data that's tabular. Sometimes GIS people call that vector, right? Vector data, points, lines, polygons with attributes behind it. It's also raster or imagery data. That could be imagery, but it also could be finished raster results, like a vegetation or a land cover map. So that's raster data. So you have these different data sets, and then you can compute and analyze it in different ways. And a lot of people are talking about machine learning. Of course, that's very exciting, but there's a lot of things that are just mathematical formulas, doing raster band math. There's just a ton of things you can do in Earth Engine that is really powerful. One thing that I think Google Earth Engine does excel at, and that's why a lot of people are interested in it, is machine learning, because it's connected to the Google Cloud and vector AI, and people can integrate TensorFlow and all that stuff, but also time series analysis, because nobody wants to download 30 years of Landsat onto their desktop, or even if they had access to their university system, like downloading it all and then radiometrically correcting it and then removing clouds, and then it's a ton of work. And I was one of the many people that learned Earth Engine for the first time, and I was like, you just did my PhD in like 2 minutes, It's like I just spent an entire course just learning how to orthorectify it. Now you don't have to. So that's the time series, bringing that in near real time, and then having that there in perpetuity is pretty cool. And then finally, being able to visualize, report, graphs, things like that, being able to port it to an Earth Engine app, or another, bring in other tools like that you may use, Esri, QGIS, these other ones, being able to do that. Those are the kinds of things where you can do visualization, do reporting, and Earth Engine can be a part of that. Okay, so a quick introduction to remote sensing. This, along the left side of there on vertical axis, is the electromagnetic spectrum. It is all around us. It is emanating from almost everything. I guess everything. I'm not a physicist, but it's definitely radiating from the sun. And so when we think about the electromagnetic spectrum, and we think about remote sensing imagery, when a satellite or an airplane with a camera takes a picture of the ground, what is it actually seeing, right? It is seeing the reflection of electromagnetic energy, and it's basically capturing that on film. That is a very simple way of thinking about what a satellite image is. But certain cameras take pictures at certain wavelengths along the electromagnetic spectrum. And if you look across from gamma rays all the way down to radio waves, The area in the middle, this area here that says visible, that's all that our naked eye sees, right? So when I'm in an airplane and you look down, like you're only seeing the satellite image or airplane image in the visible, because that's all that our eyes have the power to do, right? If we somehow got surgery in our eyes and allowed us to see near infrared, it would be pretty interesting because we would be able to see outside of the visible spectrum, and then like we would look at a tree that reflects, a green tree that reflects a lot of near infrared, and we might go blind, right? I mean, this is the kind of thing. There's so much electromagnetic spectrum happening around us. But what I want to get the point across here is that the visible, what we can see, is a tiny portion of that, and so we can set satellites and other cameras to see so much more. So for example, if we look at something we would see from an airplane, this is looking down and seeing a snow-covered area, maybe the way you would imagine it from an airplane, and that's just the visible light. Maybe there's a ski slope, I don't know what that is, or a landslide or something in some land feature. But what if we were to have a camera take a picture in the red and near infrared area? Then you start seeing, and you colorize it so we can see it, then you start seeing different features that you wouldn't have otherwise seen, for example, vegetation. If you were to go further and look at red and middle infrared, that's way outside our visible spectrum, you might see snow and ice and moisture. And so the different parts of the electromagnetic spectrum pull out different things. It's like magic. And a lot of people, when they first learn how to do this, they just throw everything in there. And that's OK. You can do that. See what you see, right? But there's a lot of scientific body of knowledge about, OK, I want to test soil moisture, or I want to understand evapotranspiration on crops, or I want to, for one of my studies in grad school, I tried to tell the difference in a wetland between different species of wetland species, because they reflect differently at different portions. So you play with things and you try to see which works best. So take that knowledge, and what Google Earth Engine does to that is it basically scales it for you so that you don't have to do that same thing over and over and over again. So for example, this is an image. This is an image of part of the Amazon. And what Google Earth Engine, and basically I'm describing parallelism right now, right, where you basically take something and you farm it out to a lot of computers. With Google Earth Engine, it takes a bunch of different pixels or a bunch of different subdivided areas, and it says, OK, everybody, you go to these different machines and you run that same algorithm, that algorithm right there. So you can see each of them runs the algorithm on their own computer, and then let's stitch it back together. And this is why sometimes you might ask a question. I want to do hydrologic modeling. I want to do network analysis. I want to do water flow analysis. And that's a little bit more difficult to do with Google Earth Engine, because Google Earth Engine is best. I mean, it can be done, but you're kind of really forcing Earth Engine to work like harder or not how it was supposed to work. Earth Engine's really good at figuring out how to do the same thing, mapping a function across all these computers. But if what you want to know is how this pixel affects this pixel way down here, that might require some special algorithm development inside Earth Engine and outside Earth Engine together. Because right now, this computer doesn't really know what this computer's doing, right? They're just doing their job really well on that one area. So that's what parallelism is, and that's one of the reasons why Earth Engine is pretty fancy, or at least we think so, right? OK, so what are the different components of Earth Engine? So the JavaScript code editor, when we were up there talking about, or if you took, maybe you took it, or maybe someone you know took it, the JavaScript part 1 and part 2 yesterday, they were learning this. They were learning, and we're going to get into this today. They were learning the code editor. This is really great for prototyping, for doing your work, for bringing in data, for seeing it in real time. If you're comfortable with JavaScript, it's great. You can build some interactive tools. You can add some UI elements. You can create apps. It's a lot of different things. It's great. You can manage your scripts and your data. This is the one I prefer because I'm not a huge Python knowledge. I don't have a lot of knowledge, and I'm sorry for that overlap. That'll be fixed later. But the Python notebook, which you can use colab.google.com to use, is an interactive Python notebook, which allows you to do the same kind of analyses, sure. But what's really nice with Python, A, if you're comfortable with Python, that's good. But B, it allows you to integrate with other Python-enabled pieces of the world. There's a lot of Python out there, a lot of Python kits and notebooks and stuff like that. So you can basically, you don't necessarily have to be in Earth Engine doing Earth Engine. You can be doing other things and calling and pulling Earth Engine to you. So Python's really powerful in that way to build these kinds of integrative tools. And then Earth Engine apps are basically the ability to take a code editor and make it a window with user elements with no code, right? And so you need to make it, or somebody on your team needs to make it, but once it's there, then you can have radio buttons and drop downs and all sorts of different functionality when Earth Engine's running in the background. So apps is really great. In fact, the team built apps because they knew that scientists and other users that were deep in the science wanted to build things for their team, for their policymakers. They wanted to just show their results that they were publishing in a paper, and they knew that people reading might not be Earth Engine users, so they just wanted to make an easy-to-use app. And so we're seeing more and more scientists take their Earth Engine results and put them in an app, we call them EE apps or Earth Engine app. And so when you think about using Earth Engine, think about this as a way to give more surface, more access to your science and your work. So diving into kind of getting to know the notebook or the code editor, if you haven't signed up for Earth Engine, then you might want to check your email and see, or if you did sign up today, and see if you got a response. Or you just want to go to code.earthengine.google.com and test it. You can do that too. And this is the time to do that so that you guys can see if you're in. If you're not, and you're comfortable looking at your neighbors, or you just want to sit back and relax, that's fine too. But this is a time where if you want to follow along, you can do that. I'm not going to go through everything here because I'm going to just show you a little bit of an example when I get to the actual live place, and you'll see me using these different pieces. But this is something from our docs, our documentation, that really does a nice job of showing you all the different pieces, because there are a lot of buttons and a lot of places, and you kind of just got to click around to see for yourself. So let's go find some data. This is, when I talked about the data catalog before, this is a great place to find, well, this is the place to find all the data. And so besides the code editor, which we're going to get into in a minute, you want to go to this page, because this is where you're going to be navigating around and looking for data. So let's go there now. And before I click away to my live demo, I want to show you that I'm going to be following these directions. These are in the slides. So if you get lost, feel free to go through the slides yourself, and we can together find your way back. Okay. Perfect. So this is the home page of the Earth Engine data catalog, and you can scroll down, and these are just some categories, but you don't have to use them because they're just a way to help you get acquainted and explore. I like browse by tags is a great way. So you can there's NASA is a tag in there, forest is a tag, air quality is a tag, methane's a tag. So there's a lot of different ones, a lot of different tags in here. And so this is a great way to browse. But I'm going to just keep going with the exercise here, and I'm going to click on Landsat at the very top. Do you see my cursor up here? It says Landsat Collections. So I'm going to click on that, and these are all the Landsat data collections. As we go down, we can see Landsat 9, 8, 7, 5, 4, 1 through 5. I'm going to go to Landsat 8. Of course, Landsat 9 is newer, but it has a little bit less data, so I kind of want to try this one here, Landsat 8. I'm going to click on that. And that just goes into the Landsat 8, and there's all these different ways that Google has with scientists advising, right, especially in the beginning, what are all the different types of data that you guys want already pre-processed, right? The top of the raw images have all the imperfections. It has the clouds, it has the shadows, it has, lots of stuff. This here is top of atmosphere. This means that haze really hasn't been removed. It's not the prettiest picture. Maybe it's not the most useful, but maybe you want that. And then the surface reflectance is by far like the most ready for you to use. That statement's subjective. You might want these others, but for now, we're going to say this is the one we want. So tier 1 and tier 2, I do know what these are. It's in my notes. but it's not something that I know all the time. I do know it though. Okay, tier 2, tier 1 meets geometric and radiometric quality requirements. Tier 2 doesn't. Okay, so we're going to go with tier 2, or tier 1, apologies. And then from there, we're going to just explore this page really quickly. So this is a really useful page because it goes into obviously the data set provider. It gives you kind of the shorthand naming convention that Google Earth Engine has named it. There's a whole description on what it is, where you can find more information, the terms of use, how you can use it, image properties, all these different image properties. And then this is the part I want to just pause on because this is going to be important. And this will also be something that Genevieve will talk about in a little bit too, is that like these band names. If you want to know a band name, this is where you need to find it in Google Earth Engine, in the data catalog. If you're like, what's the name of the red band or the near infrared band? This is where you find it. So this one here, band 3, is the green. Near infrared is band 5, SR_B. Does that make sense? So that's the name of it, of that band. Great. So I'm going to continue to scroll down. And this is my favorite part about the data description page, is I just got to click Open in Code Editor. It just comes up without any problem, knock on wood, and then click Run. And it just zoomed me in to the Western United States, just because that's a better experience than being the whole globe. And so if you guys have another area that you want to go to, that's always the first question. You want to go to the area that you guys work in, right? Here's what I'm going to ask you to do. Go to line 20. I'm going to pause in a minute so you guys can all catch up. But go to line 20 and hit two forward slashes so that it turns green. Okay? I have now commented that line out. It will be ignored by Earth Engine. And this is typical code syntax. And so if you've seen this before, it's the same kind of code syntax. Pause there. Is anybody, and this is a very safe environment. If you guys are not caught up and want to be, just raise your hand. And Alan, I forgot to introduce you guys. Alan in the back and Peter in the back, they're waiting for your hands to keep you guys on the right track. They're Earth Engine engineers. Awesome. Okay. So if you do that, then I can go anywhere. I can go over here and click Run, and it won't set the center. That's what that line of code was, setting the center. If you want to add lat long coordinates to your favorite place, you can do that, and then uncomment it, whatever you want. One quick note is that 8 is the scale or level, right? So if you want to go level 10 or level 6, you're going to either zoom in or out. I forget which, but you can experiment. All right. I just want to get back on track here, and I like that I have my speaker notes here. Okay, so we talked about bands, and this is showing visible. This is showing visible spectrum, and so this is what I would see from an airplane. But you can see here the bands are, and what I'm going to do right now is I'm going to change 4 to 5, 3 to 4, and 2 to 3. So I'm going to basically change this band 4, which is red, currently represented in the red channel, to the near infrared, represented in the red channel. I'm going to choose this one, which is, I want this to be red represented in the green channel, and I want green represented in the blue channel. I believe this is going to work. Yes, so I've just changed my image to a color infrared image. Okay, so I know this is, I'm modifying code, but anybody can do it, right? So I just changed it, and this is showing me a different type of pattern. What's cool about this is it's showing me where there is vegetation. One thing I think I breezed over it too quickly is that in the electromagnetic spectrum, near infrared is green chlorophyll in leaves and grass and trees, etc., reflects near infrared. That's why if your eyes could see it, you probably would have to wear sunglasses, go blind. I don't know, it's physically impossible. But the point is, you would definitely see a lot of reflection, if you could see in the near infrared when you looked at vegetation. So that's what I'm seeing now. I'm seeing vegetation. I just color it as red because that's kind of a conventional thing to do inside remote sensing science. This is called the color infrared or false color. Okay? Okay, so there are a lot of different band combinations. And in fact, I'm going to try to, here we are, show you. Here it goes. These are some things to try. I'm going to keep moving for the sake of time, but like these are some fun ones to try where you can see what shows floods or newly burned land. Now notice, I'm not using the right convention, right? I'm saying band 7, band 5, band 3, but this is supposed to be SR underscore, SR underscore. So you can do lots of things there. All this is doing is changing the display. I'm not really doing any analysis. But what's interesting is that all these bands are inside the image. They are there. And so what you're basically doing when you change those band combinations is really you're just changing what you see in the red, green, blue, because that's all our eyes can see. So in this case, when we put near infrared, if you put red, the red band in the blue, and you put the near infrared in the green, and you put the shortwave infrared in the red, you'll see a different type of story. You'll be able to tell a different story. And that'll give you a false color composite. If you do what we did earlier, near infrared, blue, and green, it'll give you the color infrared. And so you're basically just changing how it looks to your naked eye so that you can see these different patterns pop out. Okay, so the next thing we're going to do, and we're going to move pretty quickly, but I'm hoping you guys see kind of what is possible here, is I want to look here in the reset. These are some buttons here. You can save. You can get a link to share with someone. You can save it. And where does it save it? It saves it over here in your different asset directories. This is where the ones I own. This is the one I write. These are the ones I write to. These are the ones I read. And these are all the examples which you can pull up. And then, so if I go over here and I click reset, I'm going to just clear my script. And that just gets me back to basics. Now, my next step here is I want to go down to the example. So if you guys can see over here on the left, click on examples. And under cloud masking, I want to click on Landsat 8 surface reflectance. And the reason I'm going here is because if you'll see, this data set, this Landsat 8 data set has no clouds. And that's why I'm pulling it up, because it's going to be a much more pleasurable experience having no clouds. So I'm going to pause there and show you guys again where I found this. Over here in the scripts, if I click on examples, under cloud masking, I clicked Landsat 8 surface reflectance. And then I clicked run. Awesome. Okay. So the next thing I want to do is, if you guys prefer, go down to map.setCenter on line 32 and make it not focus on the Iberian Peninsula, unless you want that. I'm going to stay here, but you guys can go anywhere. Okay? Our different examples try to pick different areas of the planet and just show examples. Okay, so now, let me come over here. If I click run, and if I move around, it doesn't change, which is nice. So I'm going to zoom in a little bit. You can choose the different scale that you zoom to. And the first thing I want to do, well, let me go back up and say the next thing that we want to do, sorry, there we go, is to take all that data, take all of those bands that we just explored in Earth Engine, right? The near infrared band, the red, all the different bands that are in the Landsat 8 image, there are many, and we're going to use them in an intelligent algorithm to classify these different categories. That is probably one of the most common things that first-time Earth engine users want. They want to basically take a satellite image and draw insights from it. That is like the basic first move, and then maybe you want to improve upon it. Maybe you want to go deeper on the vegetation to figure out species. Maybe you want to look at the water and figure out which area is more turbid versus not. Which areas have, vegetation has more water versus not. And so there's a lot of different things you can do in classification. So we're going to do a very simple one today. And the first step is to do some training data. This is the really fun part, but it does take time. So be patient, and if you want, for now, we won't do a lot. I'm going to zoom out a little bit, actually. We won't do a lot of pins, but we'll do some just to give you the idea. Now, do you see here, I'm going to make this a little smaller. Do you see this little add a marker tool in the upper left-hand corner there? Click on that. It gives me this little geometry window here, and it automatically labels or names the first one geometry. So I'm going to click on this little gear here, and that brings up this little configure geometry import, and I'm going to call this urban. And I'm going to do something right now that I'm going to do 4 times in a row. So if you missed it the first time, you'll catch it 4 times in a row, okay? So first I'm going to make the urban category. So urban, I'm going to make it a feature collection because it's going to be a collection of features. I'm going to add a property, and I'm going to call it land cover because these are representing land cover. In code, the numbers start at 0. I don't know why. Ask an engineer. But I'm going to make the first value to be 0. It has to do with arrays and dictionaries, et cetera. And so I'm going to make the first one, which is urban, equal to 0. Then I'm going to click OK, and I'm going to start clicking where I see urban. Now, I'm doing this very lazily. Of course, if this was a true thing, you'd want to be an expert in this area or bring in your data that in a separate file that you know is urban. And so, but right now I'm just clicking on urban areas. Okay, the next thing, I'm going to add a new land cover layer, and I'm going to choose vegetation. If you want to follow along, I recommend not adding caps because the copying and pasting you're going to do later is going to use these exact names. Of course, we can help you if for some reason that was vegetation, right? Let's see, where is the vegetation? Here's some forest. Forest, forest, probably should have more than 10, but that's what's happening. Now I'm going to do 2 more. I'm going to do water. I probably should change my forest to be green. Oh, it is green. It looks green, doesn't it? And the last one was 1, and now I'm making this one 2. Water, 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 water. And then finally, I'm going to do a final one called bear. This is a very simple one. Did I choose feature collection last time? I think so. I did? Okay. I think I can double check too. Yeah, I can double check because everything I've been doing, and then I'm going to go quickly add some in the bear. There's a bear. There's a bear. There's a bear. So everything I've been doing has been, I'm going to uncheck the marker so I think that's how I do that. Everything I've been doing, no, exit, I'm going to exit. So you see my little exit next to the point drawing tool? I'm going to exit that. And now all my training data is here. And everything I've been doing has been adding up feature collections at the top here. Okay, now the rest of the time, we're going to start at row 30 and add some lines. And the rest of the presentation, which I'm going to have to, I'm going to move this, here we go. So this again walks us through it, is I'm going to copy and paste what's on these slides. And I'm going to be talking myself through it what I'm doing. In the interest of time, if you guys are like, whoa, I don't know what that's happening, we'll have some time for questions either now or after where you're like, what just happened? But I'm going to walk through what each of these are doing. So this right here is basically merging the training data into one data set so that it's a variable called training data. See how all of these are being merged? So I'm going to copy this, and then I'm going to go back into my code editor and paste. Okay, so now I've merged it. Fantastic. Next, it decides what bands do you want to use. You can use all of them, or you can use just some. As you can see, in this one, I've only used some. You can add a comma and add more for sure. It might improve it, it may hurt it. Oh, I'm going to go back here. The next one is I'm going to take those features, the urban, the bare, the forest, the water, and I'm actually going to go and, from those features, go and see what is at those bands. Tell me what is under each of these points, for each of those bands, what the values are, and save it inside your mind, Earth Engine, right? And so that's what's happening here, copying and pasting. This is I know I'm just showing, I'm not presenting at the moment, but we're going to keep moving here. This is showing all the different classifiers you can try later. And so if I get to here now and I show you, this is the I'm using CART, classification and regression tree. It's one of several or many different types of classifications you can do. And so if you want to say use CART, you can, classification and regression tree. But if you wanted to use gradient boost, you would just change SMILE CART to SMILE gradient tree boost, or a SMILE naives Bayes, or SMILE random forest. A lot of people use random forest, so you can choose that if you want. Today, right now, I'm going to just use CART. So I go to the next slide. I'm going to copy that, paste it in. I'm going to classify the image now. So I'm actually going to do the work. What just happened? Okay, good. I'm actually going to do the work now, and it's going to do the work behind it. It's not going to, oh yes, it is. I was going to say it's not going to add to the map yet, but it is, because it says map, which is my map, dot add layer. So I know, that's my clue, it's going to add this layer. It also is going to center this on all the training data. Okay, and then the final step is if you want to do a confusion matrix or an accuracy assessment. And I admit, this is very confusing. This is the proper amount of confusing code to build a confusion matrix. And what this is basically doing is it's splitting up that training data, all those points I created, it's splitting them up into a training partition and a testing partition. So it's taking a sample, doing the training, and then the other ones that you didn't use for the training, it's testing it. How well did it do? So in order to do this, you're going to need a lot more points. A lot more points. But then it gives you a confusion matrix. It's going to say, you know what, Karin, your urban and your bare are very similar. You need to have more points that are different enough to be able to do better on that classification. So I'm going to click Run. So I'm going to save that because I know I don't have enough points to do a classification tree, and a confusion matrix, and I'm going to click Run, and it's doing all of the work here behind the scenes. And what's cool here is that in my console, it's showing me some output, and it's showing me, here are some very interesting information about my classification and regression tree. It's actually telling me that certain bands are being instrumental in the decision whether it is vegetation or whether it is water. And so if we were to take this and start, tweaking or pulling out information there, then you'd be able to see more about why the blue band versus the green band are better. Okay, maybe it didn't add it to the map. It should have. Let me try this again. Oh, I see what you're saying. Ah, thank you. Who said that? Thank you. Yeah, because it basically, the layer 2 was over the layer 1. And so the way that I can fix that is by going up and moving this add layer. I'm going to add this whole thing here. Moving that above this. And then they'll be in the proper order. Well, first it'll be the image, and then it'll be the classification. All right. So we're going to stop there with the hands-on portion. And I'm going to leave you guys and ask Genevieve to come up here. But first, before I do that, let me just show you that it works. There it goes. And of course, we'd want to do a lot more work on this. But hopefully, yeah, that gives you guys a good start. All right. Forgive my moving this around. All right. Okay, so basically there's a link that you can click on to see that finished code. There's documentation, which you can actually see how is this done in the developer documentation. There are other things I want to try with you guys at some point, but I want to maybe we can do that during office hours or we can do that during a break. But really, this is what I'm trying to say here is that there are lots of examples in the scripts if you go down. If you just type in NDVI and you can click on that and click run, you'll see the code on how to do NDVI, which is a vegetation index that pulls out vegetation. If you want to do buffers, search for buffer and click run, and you can see how you can do some buffers. Maybe you only want to do a classification in a buffered area. So all of these little tools that you can link together in the code editor. And the final thing is that I encourage you guys. I know that just because of this session, you're not now a coder, but hopefully you'd feel a little more comfortable to get started on this and go a little further and you know, log in, go to the dev list, say what you want to do, get some help doing that. There's a ton of videos and resources on this website here, including this Getting Started, which is a good place to start. And so with that, I will pass it over to Genevieve. You have 15, but I know I went 5 minutes over, so.
Oh, okay. Okay.
I apologize.
No worries, no worries. I'll shorten mine. So first, it's a real pleasure to be here. Thanks, Karin. It's really nice to be here in person after all those years working, you know, virtually. So thank you very much for joining the session. So Blox, in a sense, our mission is very much aligned with the Geo4Good community to widen access to big Earth data and especially to accelerate our transition to a much more sustainable but also much more equitable and inclusive world. So I haven't really introduced myself. I'm Genevieve Patenaude. I'm the CEO of Blox. Blox is a no-code platform that sits on top of Earth Engine. I'm also associate professor at the University of Edinburgh, and my co-founder is here, Ian Woodhouse, professor and chair in active remote sensing. So before I present Blox, I want to share the reason why we created Blox. And it's no surprise here in this room that the planet is actually in a dire state. And really, the reality of having delayed action and of having no action at all are just unthinkable, really. So I like to make a parallel between human illness and planetary illness here. When someone around us is really ill, you know, whether affected by cancer, or something very simple like food poisoning, diabetes, mental illness, it's really important to get a fast diagnosis and fast treatment. And that's essential for not only recovery and survival, but also for ensuring that you have a long quality of life. But it's no different with our planet. We need tools that are fast to allow us to diagnose and treat where the planet is suffering. So that's why we created Blox. So Blox is a sort of sits on the game changer that is Earth Engine to help you, those that actually are active on the ground, to really transform and create that sustainability future, that sustainable future that we're looking for. The no-code interface really helps you customize your analyses in a way that is based on your unique needs. So what we're not doing is giving you a platform that answers completely your question. We're giving you the tools to answer the question because you are the domain expert in your field. So you don't need to know JavaScript or Python with Blox. You also don't need to know understand in depth the peculiarities of all the different data collections that we find in Earth Engine. Because every single data set is actually quite unique, as you've seen with the band labeling and all these things. So it requires quite a lot of knowledge. So we do the work in the background for you, so you don't have to have that expertise. In a sense, you're the doctors and we're the pharmacist. You're the one that diagnose and that treat, and we're the one that give you the tools to do this. So I've met with many of you over the past couple of years, and what we find in common, the commonalities between all of you, whether you can code or not, is that we're all running out of time. It's always urgent. There's always so much to do. And you have basically told me that what you need is something that's fast and efficient. And that's why we created today, and we're offering today, the Geo4Good community access to Blox for free for a period of time. So we've distributed cards on your table. If you're interested, there's a QR code there. You can join us, and that's for you to tell us what works for you. You know, how do you want us to build Blox so that it really helps propel your work? So let's now dive into how Blox work, and I'm going to use a use case here. So Ashley Bang is one of our users. She's head data scientist at ADM Capital Foundation, which is a philanthropic organization, a foundation that really focuses on environmental and societal issues across Asia. What she's interested in is really helping support communities and conservation effort in Southeast Asia. So she's looking to fund projects and to support projects where you have a confluence of different interests. So you may have, for instance, areas that are highly biodiverse, but at the same time where some species are threatened. You may also have communities which require some kind of support for livelihoods. But you might also have areas where you have commodity productions which are providing increasing pressure on the natural ecosystem surrounding the area. So basically, she's looking to find areas to support and fund. As a first-time user, Ashley would onboard Blox, and she would be given some training with a very quick video, which we're going to skip now for interest of time. Then after training, the first initial training, she would be given the choice of an area or a sector that she's interested in. So she may be interested in algae bloom or forest cover, and that would allow us to guide her through a workflow that she would build, right? Now, once she's selected the focus of her work, she lands into the main interface of Blox. So that's where you land. And here I just want to sort of describe the vocabulary that we use in Blox. So this here that you see highlighted is a workflow. And a workflow is, in a sense, is almost a Lego construction, is how you assemble blocks to create a solution that is suited to your needs. On the, that'll be your left, I guess. On the left here is where you find all the blocks. So there's a collection of blocks, and they're grouped into 3 categories. The blue blocks are the input blocks, and the input blocks are where you define your what you're interested in. So you define the area you're interested in. You define how you want to play with your collection, whether you want to remove clouds or include clouds. You define the dates that you want to look at, and so on. The yellow blocks are where you analyze. You have classification, change detection, time series, various band mats that you can do, algorithms, and you also have access there to various indices that are very specific to the work that you're interested in. So that's an example of a result after running this. In this case here, it's a very simple workflow just for the case of showcasing here. You would press play. What we've done here is we've selected the UK, and we're showing elevation data for the entire of the UK. So now let's look at something a little bit more complicated, something that's relevant to what we've just done with Karin, so classification. Ashley, in this case, is interested in finding out where can I see where there are industrial and smallholder palm oil plantation that are surrounding built environments, so that's villages, where we can also find more old growth and natural forest and agriculture. So areas where you have that confluence of different interests. So this is how you would run a workflow. So you could either, here we're focusing on Borneo, you could either draw your area of interest or basically upload what we call a shape file. You add to map, and that we're now focusing on the area of Borneo. Now you drag and drop and pull down the menu to identify which data set you're interested in within the collection of Google Earth Engine. In this case, we've chosen Landsat. And here we've done the work to assemble all the Landsats together so they're unified. And I identify here that I'm interested in this area, not in a country, just this area in particular. Now I drag and drop the date. And note that our blocks are dynamic, so the dates are associated with the data set. There, it doesn't give you below 1982 because Landsat is not available in that case then. So we're looking at 2 years because it's a very cloudy region, right? We're in Borneo. So we want to make sure we're going to have some images from all the images that have been collected between those 2 years. We're going to now filter those that filter out. We're going to bin the ones in the pixels that have more than 70% cloud cover. And now I'm going to create a composite image. A composite image is also almost a sort of summary image, a synthesis image, combining all the best stuff from all the images that I've kept in my collection. So we're not going to see it now. I'm just saving this because I want to use this in my classification. So I'm saving this as a Landsat composite, and I indicate the date. And because I work in a team, I'm just telling the team what I'm doing so that they can use that workflow later on. Now I'm bringing a new data set. Here we're going to use SAR data. So Karin spoke about the micro electromagnetic spectrum, and here I'm playing with microwave data. And SAR is really helpful to pick up on structure of assets on the ground. So now here I'm looking at creating a composite over every month of the year because I'm interested in looking at how different land cover change over the year. So agricultural fields will change a lot. They'll be harvested, where a forest will stay the same. So that will help me in my analysis. Again, here, I'm just tidying up a little bit my workflow. And here I'm going to do my analysis. And you can see there's plenty of other blocks, but here we're focusing on classification. So you'll see that I'm selecting the algorithm random forest, but if I were to press the drop-down menu, you would have all the other classification algorithm available to you. So this now brings the 2 data sets that I've just created that I'm now inserting to create my classification. And I'm now creating a map layer that is going to be inserted here so that I can see. So that's allowing me at the moment to identify a palette of colors where you can really discriminate between the different land covers. So I have some flexibility as to what I can do. I like a tidy space, so I'm just cleaning up. I wish my kids were like that too. So what we're going to see now is that the different land classes, the legend is going to show us what's going to come out as our analysis. So the dark green are the trees. We have the really dark trees is palm oil plantation, and the teal is sort of smallholder palm oil plantation. And then you have the sort of more lighter green, that's the trees. And where you have the red and the orange is where we find the villages and the surrounding agricultural fields. And again, here, just like in Google Earth Engine, you have access to all your confusion matrices and your accuracy of your classification and so on. So that gives you, hopefully, a good overview of how EarthBlox works. It really does provide the power of Earth Engine, but for those of us who are not coders, but still want to really benefit from the power of satellite imagery and spatial data in a no-coding way. Yeah, there you go. So that really gives Ashley the possibility to be in a driving seat. She can take her analysis in whatever direction she wants. And ultimately, it doesn't stop at the classification where she's identified the land use. She can actually look at nighttime lights and see, okay, out of those villages, which ones have access to electricity and which ones do not. She can also do change detection to see, well, where do we see illegal deforestation happening? She can do time series to see, well, what historically has happened in this area over the past 20, 15 years and so on. So that gives her a lot of power to conduct her own analyses in the way that she wants. So that's just to conclude some small little tips that can help you really accelerate your work. Our blocks are dynamic and they're intelligent. So every time that you pull a data set, like in this case I'm showing Sentinel-2, you'll see that it adjusts the date range. So you don't have to look every time that you're uploading a data or working with certain data set to know when this data is available for. It does that for you. We also created dynamic banding and standardized the banding. So one of the key complications of the sensors is that they each have a different way to label their bands. We just basically use the English language. A red band is a red band, no matter what sensor you work with. Near infrared is near infrared, so it's standardized throughout. We also have dynamic indices. So if you work with radar data, it won't show you these indices. It'll show you different kind of indices. So you have indices specific blocks. So I'll cut this short because I understand we're running a little bit over time here. But if you're interested in working with us, we're really keen to make this tool for you guys, right? We're a purpose-driven company. We really want to accelerate your action on the ground. So scan the QR code, come and join us, use our tool and tell us how you want EarthBlox to develop in the future so we can really leave a positive impact on this planet for the future. Thanks. Thank you very much.